Hi, this is Nathan Tintel. In this Learning Goal video, we will talk about how to compute and apply the MAD statistic to a data set. We will use the coming to a stop example from the Introduction to Statistical Investigations textbook. To apply the 3S strategy to this data set, the first step is to compute a statistic. Now keep in mind that a statistic is, as the word suggests, a single number, not multiple numbers, that summarize the evidence against the null hypothesis. As a reminder, the null hypothesis in this data set is that there's no association between the order the car arrives and whether or not it stops. That is, that the proportions are the same in each of the three groups. So what have we done before when we've had this kind of data, that is categorical data? Well, we've used the difference in proportions. Up until now, there have only been two proportions to compare, and so we've subtracted those numbers from each other, and we've gotten one number, the difference in proportions. But now there's three proportions, 85.8%, 90.5%, and 77.6%. We know that we need to compute a single number from these three numbers. So how are we going to do that? Well, one way is to start by comparing each of the groups to another group. So we can take the lead group versus the following group, subtract them, and get a difference. So we get three different differences. And now the question is, well, this gives us a sense of how different are these groups from each other, which in some way is measuring how different from the null hypothesis is this data. But how can we take these three numbers and combine them into a single number that gives you the evidence against the null hypothesis that all the proportions are the same? Well, one option is just to average them together, 12.9%, negative 4.7%, and negative 8.2%. And if you do that, you get a value of 0. And that seems a little bit less than optimal because these proportions obviously are different, and so instead make them positive first and then average them together and you get 8.6%. So what is 8.6%? 8.6% is the average difference between the proportions where we've made sure that all those differences are positive so we don't have cancellation. That number, 8.6%, is the MAD statistic. It is the mean absolute deviation, that is the average positive differences between the groups. So, to compute this, take all the differences in proportions, make them positive, average them together. That's your MAD statistic. Few words of caution. Is the MAD statistic the only option out there? No, many different options are available, but they will yield different power. And so this particular statistic is fairly powerful. That is, that the chances of a type 2 error are fairly low against lots of different scenarios. If you anticipate particular scenarios in your data set, in other words, particular ways that the alternative hypothesis is true, you may be able to come up with more powerful choices of a statistic, maybe just comparing two of the different proportions. The MAD statistic, as we presented it to you, really only works when one of the variables is binary. That is, one of them has two categories. You can look at extensions that go to multiple categories. We're not really going to show you that here because there is another statistic called the chi-squared statistic, which is used to conduct theory-based tests. That's a more versatile statistic. We'll talk more about that in other Learning Goal videos. Third, the MAD statistic is a natural extension of what we do when we compare two proportions. In fact, you can use the MAD statistic to compare two proportions, but when you do that, because you're taking the absolute value, that is, you're making the value of the difference positive, in turn, you're always doing a two-sided test. And finally, don't forget to make the differences positive before you average them together. That's a common student mistake. You end up with cancellation. The value of the statistic is not as large or informative as it should be.